This video, part 3 of 3 on the days of Noah, is dedicated to Christ our Lord, for graciously hearing our prayers and restoring our Marie to us. Amen. Yeshua HaMashiach, Baraku.
Scriptural Insights presents the Book of Revelation.
The revelation of Yeshua HaMashiach, as recorded by Saint John the Prophet. I am your host, Nanny Ruth, and your reader for this blessed book, with Marty on insightful thoughts and Marie on scriptural cross-references and commentaries. Today we embark on the special topic, Part 3 of 3 on the days of Noah, an exposition on the number that perished in the Deluge, and pray the Ruach HaKodesh would help us to rightly divide the Word of God. Amen. All scriptural readings and references are from the King James Study Bible. In the 600th year of Noah's life, on the 17th day of the second month of Iyar, about 25th of May, or pre-flood, 20th of May, were all the fountains of the great deep broken up. And 8.7 plus or minus 0.13 billion souls perished. And God's reason for the deluge. In a nutshell, because of Genesis chapter 6 verse 4, namely Satan's attempt to foil God's Adamic covenant, a promise to send a redeemer as the seed of the woman who would crush the serpent and so secure the devil's defeat. And by corrupting the human genome with demon seed so that the redeemer, Yeshua, would be born of demons, and so by God's own word to redeem humanity in its fallen state, as the third part of 3 from among the undecided angels only, would then be obligated to redeem some of Satan's angels, as the second part of 3 or the rebel angels, that warred against Michael and his angels as the first part of 3 or faithful angels to Yeshua, their commander and chief or lord of hosts. Baraku, blessed be he.
In this tutorial, we shall waver the popular statistical tools, like applying compound growth, similar to compound interest based on a geometric series like P plus P times G plus P times G squared, etc., where P is the initial population count and G is the growth rate, to arrive at an answer, or even the population doubling time, as the time it takes for the population, n of k to double, and k is the number of doubling. Instead, we shall favor the differential growth rate per capita approach, defined as the difference between the birth rate and the death rate, divided by the population count, say n of t, where t represents the variable time. Now, ask yourselves, what are the primary ingredients to knowing the size of a given population at a given time, or as a function of time? It's just like knowing the remaining charge in your smartphone battery at a given time, while it's plugged and charging, and you are using it at the same time, and so draining the battery, concurrently. Clearly, it's the difference between your charge rate and the drainage rate, of course. And so in like manner, the difference between the birth rate and death rate, gives your net population growth rate. If positive, then you eventually will eat yourselves out of a house and home. If negative, then sooner or later you will be on the endangered species list. Get the point? Now, given the growth rate as the difference between the birth and death rates, how would a single individual from the population contribute to it? Simple, just divide the growth rate by the population count or n of t, to get the growth rate per count or individual, and so get that individual's contribution, either as a positive or negative number, called a surplus or deficit respectively, to the growth rate, which is now officially called the growth rate per capita, implying per individual. Next, we set up the equation for our population differential growth rate per capita, which we must then solve. Recall the term equation implying equality or being equal or having 2 parts, called the left-hand side, and the other the right-hand side, connected by the equal sign. Recall also the cardinal rule: whatever action or operation you do to one side, say divide by n of t, you must also do to the other side, in order to preserve the integrity of the equation. On the right-hand side, we have the population growth rate per capita, discussed earlier, but now we must assign a definitive number to it. There are two alternate approaches, to include Enoch, the odd one out, with a much shorter lifespan reducing group average from 900 to about 850 years, or to exclude him. We favor the former case, since his progenies left behind matters in the final analysis. We first have to estimate the average children count per family of two parents. Assuming as before a maximum count of 56, like for Adam and Eve, to as low as 5, from the expression sons and daughters implying at least 2 of each, which equals 4 plus the firstborn patriarch for at least 5, then yields the average birth rate of 30 children from every pair of, obviously fertile parents. But, what about infertile people, who nonetheless contribute to both the death rate and population counts, and so the net growth? Assuming up to 3% of the offspring population suffer this fate, we absorb this negative contribution by multiplying the 30 children per family by 97%, which gives on average only 29 children that will be fertile. Next, we need to assess their death rate per family, which is simply the demise of the patriarch, including Enoch that vanished, plus only one spouse and up to 3 children for whatever reasons unknown, to arrive at 5. This gives a growth rate, from the difference between the birth and death rates, of 29 minus 5, which equals 24, divided by the reduced lifespan of 850 years, which equals 0.028 per year. Finally, we divide by the parent count of 2, since it's from every paired male and female, that yields this result per family per year, to get as the growth rate per capita, or per individual, of 0.014. Now, given the growth rate per capita of 0.014, for the right-hand side of the equation, we now focus on the left-hand side, which is the generalized form, like a generic brand X without a specific label, of the definition of growth rate per capita, qualifying the right-hand side as the specific label if you like. In calculus, if you want to express the rate of change of any variable, aka any measurement, say, brand X with respects to another, say, time t, you would write it down symbolically as dx divided by dt, but properly pronounced as the derivative of x with respects to t. For example, if x equals L for length, then dl over dt is just the speed of, say, your vehicle, etc. Now, let's retain the time t, but replace the length for the population count, denoted by n of t, then how this variable would change over time would be expressed symbolically as dn of t, divided by dt for the population growth rate with respects to time or over time. Finally, to fulfill the definition of growth rate per capita, we must divide this growth rate by the population count or n of t. Hence, this defines the left-hand side of our equation. And the survey said, dn of t over dt, divided by n of t, equals 0.014. How would you solve this equation? Just like in algebra, under the cardinal rule of multiplying both sides with the same quantity, in this case try dt, to get dn of t over n of t, equals 0.014 times dt, as shown. Remember, the goal is to isolate the population count, or n of t, as the only quantity on the left-hand side as a standalone, to be equal to some fancy formula on the right-hand side, that defines our solution. In mathematics, many operations, aka operators, have their inverse counterparts, to undo or neutralize the other's effect. For example, addition and subtraction, multiplication and division, logarithm and exponentiation, and as it pertains to calculus, the adjectives, derivatives and integrals, or as nouns, differentiation and integration. Since we are all familiar with the first two pairs, let's start on the third pair. We all know how to square or cube any number, say 10 squared to yield 100, and denote this as 10 raised to the power of 2, where the number 10 is called the base and the number 2 is called the exponent. Given that, how can we reverse the process to extract the exponent, namely, the number 2, from the number 100? That's where the inverse operation of logarithm comes into play, the word log, short for logarithm, reserved exclusively for base 10, or common logarithm, when applied to the number 100, written as log of 100, gives the exponent, or the number 2 technically, referred to as logarithm of 100 to base 10 as the answer. Now, let's try this again, but not with the common base 10, Instead we use the more popular Neperian base value of 2.71828 to 5 decimal places, referred to as natural logarithm, but all the other concepts and rules still apply. Let's cut to the chase. If we were given the natural logarithm of the population count, n of t written as ln of n of t, how would we extract the desired n of t? Simply, by eliminating the logarithm operation, of course. But, how would we accomplish that? By applying the inverse operation of exponentiation upon it, of course, and this is expressed or written as exp of ln of n of t to equal simply just n of t. Get the picture? Next, differentiation and integration. Finally, let's address integration as the inverse operation of differentiation. Suffice it to say, given a variable x, then the derivative of the natural logarithmic function of x with respect to x is just 1 divided by that x. So, if x were say n of t, then the derivative of ln of n of t with respect to t is 1 divided by that n of t times dn over dt. So, if we were given the population per capita equation derived earlier, how would we eliminate the differentiation process to recover the quantity, n of t? We integrate it, of course, and this is how we would simply write it all down on paper, as shown, where the elongated s is our reserved symbol for integration. Now, referring to the equation above it, and multiplying that equation by dx, on both sides, cancels on the left-hand side, but appears on top of the x on the right-hand side, as shown. Now, let x equals n of t again, and we have the results, as shown. See anything familiar? Hence, the integral on the left is just the integral of d, ln of n of t, as shown. Agreed? Since integration and differentiation cancel, we are left with just ln of n of t, on the left side. What about the integral on the far right? That one is easily evaluated, since the quantity between the integral sign and dt, just so happens to be a constant, and its final value is just that constant times t, or 0.014 t plus some arbitrary constant, which can be determined by a single boundary condition. This method of approach is known as indefinite integration. Instead, we will opt for definite integration, which will still need the results arrived here as a prerequisite, but we may dispense with the arbitrary constant completely. It will entail evaluating the indefinite integral at two extremes, then subtracting the value at the lower extreme from the upper as the final result. It's that simple. And this is how the revised integral equation would look like written down, where the quantities above the integral sign are the upper limits of integration at one extreme, and those at the bottom are the lower limits of integration at the other extreme, and we will address them shortly. But first, back to our indefinite integral results, we need to implement or integrate those limits into them for our final formula, both for left and right hand sides. Let's start with the left hand side. Recall from Nanny's and Marie's sessions that the flood came at time t equals 1656 years relative to Adam's creation, at time t equals 0 respectively. So, n of 1656 defines the population that perished. Likewise, the population at ground zero, or t equals 0, was just Adam. No Eve. She came later in Genesis 2:22, after Adam named all the land and air creatures from Genesis 2:20, but more importantly, Adam and Eve obviously couldn't procreate pre-puberty, and that came post-eviction from Genesis 4:1, when he was at least 71 years of age. Recall, even today girls mature faster than boys, reaching puberty at 12 versus boys at 13, and even so Eve, younger than Adam by several years, they reached puberty together post-eviction. Hence, 71 years for the lower limit of integration on the right side, and so n of 71 equals 2, for the population count of Adam and Eve on the left-hand side respectively. Now for the left-hand side, plug the upper limit into ln of n of t. Then repeat for the lower limit, and subtract the lower limit from the upper to get ln of n of 1656 minus ln of 2, which equals ln of 1656 divided by 2, for the left side. For the right side, we have just 0.014 times 1656 minus 71, or 22.19. Now, we apply the inverse operation of exponentiation to both sides to arrive at the final formula, n of 1656 years equals 2 times the exp of 22.19. Plugging that into our smartphone scientific calculator gives for n of 1656 years, just under 8.7 billion people that perished. Now that we are familiar with the math and have a formula to estimate the pre-flood population from Adam's creation, is this even a fair reference point, since he and Eve were pre-puberty in Eden and so in that state, could never contribute to any birth rate? Instead, we should adopt Adam's puberty at 71 years, as our reference, and subtract it from 1656 or any other time value, for a more realistic estimate. Agreed? And while we are at it, how about eliminating the need to manually subtract Adam's puberty age of 71 from any input time t, by having the formula do it for us automatically? Here's how. Let t asterisk equal t minus 71, then n of t asterisk equals 2 times exp of 0.014 times t minus 71, which equals 2 exp of 0.014 t divided by exp of 0.014 times 71, which equals 2 exp of 0.014 t divided by exp of 0.994, which equals 2 exp of 0.014 t divided by 2.702 to arrive at 0.74 times exp of 0.014 t, where t is from Adam's creation as before. Note, the only difference is replacing the coefficient 2 with 0.74. Now, let's test our revised formula. First, at Adam's puberty age of 71, we have n of 71 equals 0.74 times exp of 0.014 times 71, which equals 0.74 times 2.70, which equals 1.99, or rounding up to 2 people, namely Adam and Eve, of course. What about at Seth's birth? Namely, n of 130, which equals 0.74 times exp of 0.014 times 130, which equals 0.74 times 6.172, which equals 4.57 or borderline. Recall that both the birth and death rates contribute to the growth rate, hence we can either round up to 5 and celebrate Abel's contribution to the birth rate, or round down to 4 and mourn Abel's wrongful death applied to the death rate. Either way, it's correct, and the other 4 members of the population were Adam, Eve, Cain, and Seth, of course. And again, for a correct overall estimate, to properly bring math and science calculations to closure, we should provide an accompanying margin of error, aka plus or minus some uncertainty factor. We will adopt the conventional standard deviation, or SD, from a normal or bell-shaped curve, defined as the square root of the average of the squared differences between a set of values from their mean value, where the Greek symbol sigma denotes the summation from lower index I equals 0 as first entry, or Adam, to the upper index 8 for last entry, or Lamech, and the patriarchs' population contributions are denoted by pp of I, where pp of 0 is for Adam, pp of 1 is for Seth, and so on down to pp of 8 for Lamech, and their mean or average value is denoted by m, defined as the sum of all the pp of I values divided by 9, and sqrt represents the square root of. We will only outline the procedure here, using one of the 9 patriarchs for illustration, but will show their final results, yes, for all 9. You must repeat the steps for the remaining 8 for yourselves as an exercise, if you wish to confirm our final result. To exemplify, given any patriarch, say, Lamech, we estimate his and his descendants' offspring contributions to the community population, and only over Lamech's fertility window, assumed to be at half his lifespan, and starting from his puberty or first post-puberty opportunity to mate, assumed to be from his firstborn. Remember, our formula, 0.74 exp of 0.014 t, automatically subtracts Adam's puberty from our time entry. T can now be referenced from Adam's creation, so don't do it twice. Okay? For Lamech, born 874 years from Adam's creation, with a lifespan of 777 years, and so fertility window of 388.5 or 389 years, begotten his firstborn Noah at 182, but conceived 7 years earlier at 175 relative to his birth, or 1049 years from Adam, as his puberty. To this year we must add the fertility range 389 to yield T equals 1438 years, and defines the end of Lamech's fertility from Adam. Next, plug this into our growth rate per capita formula, by first multiplying by 0.014 to yield 20.132, then the EXP of this is just 553,618,543.63, rounded down to 553,618,543, and last but not least, we must multiply by 0.74 to get 409,677,722, for the estimate of Lamech's and his descendants, only, contribution to the overall pre-flood population. Get the picture? When we repeat this procedure for the remaining 8, you must start with Adam to Seth, then work your way down finally to Lamech, in that order. You should arrive at a total sum of 538,030,360, next divide by the number of patriarchs, or 9 to get their group average of 59,781,151. Finally, subtract each of the patriarchs' population contribution from this group average, in turn, then square each of these values, add them all up and divide their sum by 9 again, to arrive at a secondary group mean, not the same as the first one. Now take the square root of this secondary group mean, to arrive at the rounded off standard deviation of 129,439,255 or 0.13 billion, as our margin of error or uncertainty factor. Hence, the estimated pre-flood population that died was 8.69 or rounded off to 8.7, plus or minus 0.13 billion lost souls. It's interesting to compare this number with our current population, which was 8,045,311,447 at mid-year 2023, and exceeded 8,075,458,849 by the end of 2023, into January 3rd of 2024, at over 8,082,995,700, according to UN and World Population Today sources, respectively. It's also intriguing to include a new research by the Deutsche Bank, and reported by CNBC, to peak at 8.7 billion in 2055, about 31 years from now, which so happens, by chance, to coincide with our Deluge estimations, then by 2056 to decline back down to 8 billion by 2100. What are the obvious ramifications? Currently, we have a positive global growth rate, with birth rates at approximately double the death rates. But this must be reversed, implying the global death rate must first catch up and equal the birth rate at the peak, then exceed the birth rate between 2056 and 2100, only to balance off again with a birth rate by 2100. Agreed? Implying a net death rate that would supersede any growth rate by 700 million or 0.7 billion, divided by the population of 8.7 billion, for the per capita result of 0.08 or 8% over 45 years, from 2056 to 2100, averaging to a negative global annual growth rate of minus 0.18%, to be sustained over 45 years. So, what could be responsible for such a high global mortality rate? Anything from natural disasters, to global war or even radioactive fallout, and so death from radiation sickness, from an accidental or intentional nuclear detonation, to natural proliferation during wartime, of contagious diseases, or even mandatory global contraception, etc. Take your pick. However, it's a far cry from the 8.7 billion that were lost in the deluge. Agreed? Make no mistake, God didn't send the flood because of the population count of Noah's days, but rather because of Genesis 6:4, and Satan's attempt to foil the Adamic covenant of Genesis 3:15, which our Nanny's introduction clarified. So, the Deutsche Bank's projection, if accurate, of the demise of over 700 million people between 2055 and 2100, will have to be from either natural calamities, and or from our own, human failures. Finally, a comparison between our differential growth rate method, with the population doubling and compound growth rate methods. First, assuming the latter two agree on the pre-flood population count, say n of k or k prime, so we can equate them, and arrive at an algebraic equation as shown. We have p, the initial population, times 2 to the power k, or d for the number of population doublings, equals p prime, allowing for a different initial population, times 1 plus g, where g is the annual growth rate, to the power of k prime, or t the time from Adam's creation to the deluge. Setting p and p prime as shown, I will explain shortly, and simplifying, and taking natural logs of both sides and rearranging, yields t divided by d prime equals ln, or natural log of 2 divided by natural log of 1 plus g. Now, implementing our own calculated annual growth rate per capita of 0.014 for g, and substituting it into the equation and solving first for t divided by d prime, or doubling time for the first 1,650 years, yields about 50 years, in contrast to the proposed contemporary 74 years. In other words, today, our post-flood population might double every 74 odd years, but the pre-flood population doubled every 50 years instead. Next, we solve for d prime as t, time from Adam's creation to the deluge, or 1,656 years, divided by the 50 years, to give 33.12 or 33 complete doublings as d prime over the first 1,650 years and only 0.108 for the last 5.4 years, or 10.8% into the next dth or 34th doubling. Finally, substituting this d prime equals 33 doublings, into the population doubling time formula, on the left hand side, with initial population of 1, yes, just Adam and his spare rib as our first doubling, then came along Eve as our second doubling. Get the picture? We arrive at a population count of 8,580,934,592, but we must add back the 10.8% of the 34th doubling, or 1,855,425,872, to the 1,650 years from the 33rd doubling, for a grand total of 10,436,360,464. About 20.06% larger than our estimation at 8.7 billion. Similarly, by substituting our annual growth rate of 0.014 into the compound growth rate formula, but this time with an initial population count of 2, yes, Adam and Eve this time, since it takes 2 opposing sex to procreate, we arrive at 9,973,635,116, about 15% larger than our projections. So, in the final analysis, if we consider all 3 methods, then the pre-flood population was between 8.6 and 10.4 billion people, or averaging to 9.5 billion, give or take about 900 million.
Until the next time, you are cordially invited to review all our other free YouTube videos on controversial Christian topics. Just do a YouTube search on videos by 177 Enoch, and specifically on the Book of Revelation by Enoch 177. Finally, remember from Revelation 19 verse 10, the testimony or teachings of Yeshua is the spirit of prophecy. This is your host Nanny Ruth, and on behalf of the troops, Marie, Marty and the Ruach HaKodesh, who leads us into all truth, we wish you a most blessed day in Yeshua, Baraku.